අලුත් දැන් නොතරන ජාතියේ ලෝ නොනගී කියලා කුමාරතුංගයන් කිව්වේ මීට වසර ගණනාවකට ඉස්සෙල්ලා. අපේ කතාවේ තියෙන නියම යථාර්ථයේ නියම ගැඹුර පේන්න අරන් තින්නේ මෑත යුගයේදී. ඒක අතකින් ලාංකික විදිහට බලාපොරොත්තු විරහිත සිහින විරහිත කාලයක නව නිපැවුම් කරන අපේ දුවදරුවන්ට මම හිතනවා මේක අනගි අවස්ථාවක් කියලා. සිහින දැකලා වැඩක් නැහැ. සිහින යථාර්ථයක් බවට පරිවර්තනය කර යුතුයි. සිහින හඹා යා යුතුයි. සර්කිටෝ 21 කියන්නේ සිහින හඹා යන අපේ දුවදරුවන්ට ශ්‍රී ලංකා තාක්ෂණික විශ්වවිද්‍යාලය එහෙමත් නැත්නම් අපි හැමෝම දන්නේ SLT කැම්පස් එක හදලා දීලා තියෙන අනර්ග අවස්ථාවක්. වැඩෝ ඉන්නව නම් මෙන්න අවස්ථාව. අවිල්ලා පෙන්වන්න ඕගොල්ලොන්ගේ වැඩ ටික සර්කිටෝ 21.
Hello and good evening to everyone. Welcome to another session of CIRCUITO', Amp Up Your Electrics. I doubt we have to introduce ourselves to any of last week's participants, but in the case any one of you missed the first session, I'm Sonal Disanaika.
I'm Tharshili Yanage.
And we will be your moderators tonight. I don't wish to take too much of your time today, but there are a couple of announcements that we must make before we get started. And Tharushi, if you would do the honors.
All right, Sonal. Firstly, I would like to remind all the participants gathered here today, we will be taking your attendance. So please fill out the Google form that will be shared in the chat box later. Also, there will be a Q&A forum to collect and collate any questions you might have during the session. The link can be found in the chat box and in the WhatsApp groups affiliated with CIRCUITO'21. And that's all covered. Now, I warmly welcome our resource person, Mr. Rwanta Pushpika, a mechatronics engineer from the Institute of Innovators, to the second session of the PCB workshop series conducted by CIRCUITO'21. It's an honor to have you with us again, sir. I invite you to address the gathering.
Okay, thank you, Tarushi. Good evening, everyone. I think everyone of you could hear me clearly, right?
Yes, sir.
Okay, so without further ado, let's get into the lesson. Okay, let me share my screen. Okay. Can everyone see my screen clearly?
Yes, sir, we can.
Okay. Good evening, everyone. Last week we had an introductory session about like theoretical aspects of PCB designing. This week we are going to actually try those things in practice. Okay, so as I said in last time, I think most of you gone into the ECEDA website and created the account as I instructed last week. So if you haven't, please create account, or you could log in using your Google account as well. Okay. So first you have to go to this website ecda.com, and then you could log in or create an account from here. So I already logged in. So then I'm clicking this ECDA designer button. Okay, so this is the you can see. So this ECDA software has two options. As I said last week, you could design schematics and PCBs. Not only that, newest update, by clicking this button, you could do simulation as well. If you need to test your circuit, if you know to if you want to know how much current flows in your circuit, etc., you could use this simulation mode. So in this course, I'm not going to cover the simulation part. Okay. So let's go through the interface really quickly. So on top of there, you could see the regular file menu and options and settings menus. Special area where we have all the projects. As I told you, this is a cloud-based software. You don't have to install anything to the computer. So your projects are stored in their cloud. So since I have designed a lot of PCBs using this software, there is a lot of projects inside this project area. And then using this eLib and library buttons, we could select components. I am going to show you how in a while. Okay, so this is the area where we are designing the PCB. Still, it's populated with the start screen. Okay, let's start a new project. So by this point, so since this is a innovation competition, so we hope all of you have something in mind. So I explained the design process last week. So before going to do the PCB designing part, you have to have a proper schematic. And then only you need to go to the designing phase. PCB designing phase. So I think rather than going through each and every menu and component, I thought it's better for you to introduce the software while doing a small activity, small PCB. So I think some of you could guess what I'm going to draw. So this is a very popular circuit. If you have started electronics in your school days, maybe grade 6, 7, 8, you might have probably designed one of these as your one of your very first circuits. So this is the Knight Rider circuit. So I think every one of you have bought a PCB from shop and at least assembled this, or likewise. If not, please. This is like Hello World in electronics, Hello World for programming. So we are using this legendary circuit to teach you about PCB design. So this is the schematic. So we, for now, this is just a picture. Step by step, I'm teaching you how to enter this into our ECDA software. Okay. Firstly, let's go to File and go to New and New Project. So although you could design PCBs and schematics without a project, since we have to encapsulate the project and the PCB, so it's easier to share. I'm instructing you to create a project first. So you could put a project name. CIRCUITO'E. You could use any name. And for the description, you could enter anything. I mean, if you are doing actuator, to have a description, else when the number of projects grows, it will be harder to track based on our name. Yeah, and then after saving this, this window gonna pop up. So in this window, this is the schematic window where we could draw the schematic. So a lot of tools and menus pops up. I'm going to introduce you to them in a while. So this is the area where we're going to draw our PCB, where we're going to place our components and draw the PCB. So this is the sheet. At the bottom of the sheet, there are, when designing a PCB, you have to learn the shortcuts of the program. So in that way, you could navigate through the software quickly. So like other softwares, by using scroll wheel on your mouse, you could zoom in and out from the design area. And if you need to move within your sheet, you could press the middle mouse button and drag. Okay. Likewise, you could move around the area. So in this window, this menu, you could change the attributes of this canvas. Okay. You could change the background color. I mean, this does not affect the final PCB, the physical PCB we get, but this will make your process familiar to you. So we could change the grid size. We could change the paper size sheet to draw the schematic. If you need more space, you could always can choose another paper type. Okay. And the bottom of this, if I zoom in, I think this part is familiar if you have ever seen plan of a house. So this is also the same. If you are doing this professionally, it's better to enter your company details, name, and the date, and the revision, title, etc. So further down the line of your product development process, you could track this, and as well as if you are going to present this, it's more professional. Okay, I'm advising you to do this as well. So I'm for the company, I'm entering 𝐸𝐸.𝐿𝐾 for the title. I tried it. Okay. So this is circuit we are going to draw. So as you can see, there are two ICs. So usually we are placing these ICs first because those two are the most complex component in this circuit. So first we are going to place this 1470 decade counter IC. So from there's an option called 𝐸𝐸 here. So by pressing this, you could get symbols for common components like resistors, capacitors, variable resistors, connectors, etc. Okay, LEDs, even these 7-segment displays as well. So I think you could see like this 4070 IC, you cannot find that from here. So because that's an extended part, so there is only limited number of basic parts. There are millions and millions of extended parts. Anyone could create a part. So for that, they created this part library. If some part isn't in this area, you could find it from this library. Every PCB designing software has a library, but the benefit of this ECDA libraries, since it's connected to the cloud, you don't need to say some new part released from released by Texas Instruments, new IC. So you don't need to create your own part. You just, this ECDA company automatically updates the library from their side. So we could search them quickly. So I'm clicking on the library, and then this search box appears. You could search 70. Okay. So in here, we could see a lot of options for this same IC. I haven't explained, I have explained like for the same component, there are mainly at least two varieties. One is through hole component, one is surface mount components. But depending on the application, there could be many more varieties. Say your IC is used in a consumer application, medical application, or military application. For the same IC, there are different versions that specially designed for different scenarios. So for this IC, we have like maybe like 50 options to choose from. To avoid confusion, what I'm going to use is a electronic suppliers website. For this case, I'm using this website called LCSC because it's integrated into ECDA as well. And this is the same company. They give you this PCB designing software as well as a marketplace to buy components. You could search through your components. I'm entering CD 4017 and searching it. You could see the parts. Or you could go to the library. You could click on these parts, and then you could see the actual like 3D view of the IC and the footprint of the IC, as well as a symbolic view of the IC. So each component, if we click on this, we could see. So see, this empty version is so this BE version is basically, if you can see this, these have the pins. So it's a through hole component, but this has okay. So and this footprint section, you could see more information about this. You could even if you need to find the data sheet, you could click on the component and you could press this button, and it automatically opens a data sheet for the component like that. So in this case, I'm going to select this 4017 BE version, where there is this through hole components with the item to anywhere, and once you need to place the click, then I am getting the other IC as well. So it's 555, another very popular IC. 555, by using 555, we could generate pulses, different pulses. It's used in many applications. Everything from blinking LEDs to creating FM transmitters as well. And I'm going to the design library again and entering 555. Okay. So I'm using this variant called NE555. For this also I'm selecting a through hole version and I'm placing it on the board. So it's a little bit easier if we orient this according to this schematic, but okay, in this case, yeah, let's keep like this. Okay. Okay. So then we are going to add the rest of the components. Okay. Okay. So if we need to rotate the component, you could click on a component and press space. Okay. Then you could rotate the component. Yeah. So I am adding the rest. First, let's start from this area. Let's complete this 555 timer section first. So there is this BC547 transistor and bunch of resistors and bunch of capacitors and a diode as well. Okay. So first, let's wire this discharge connection. So there's the supply where we hook up 9 volt or 12 volt supply. So first, let's place this discharge area. So this. So first, we need to mark the power line. Okay. So we are using this VCC symbol and then placing it here. So this menu has the wiring tools. There are these wires to connect between components like this, and there are other things called labels, which I'm not going to explain today. Okay, so first, so initially we need to give power to these two components. So I am adding this VCC object and connecting using this line net option, wire option. Okay, and then we are going to place these two resistors. So I told you there are these two families of components, basically through hole and surface mount components. So by using surface mount components, you could reduce the space. For even these two ICs, I could have used surface mount components, but in this case, I'm not using them. But to show you how, I'm going to, for the other components, these resistors and the capacitors and these diodes, I'm going to use surface mount components. So I'm going to this 𝐸𝐿ED menu because the other components are not special. They are like common components we could find around. So first, let's add this 4.7K resistor. So you could go to 𝐸𝐿ED menu, and then I think you all know the circuit symbols. If not, you could look it up in Google. So this so there are two symbols. So one is US symbol, other is European symbol. So there is no different. Just the symbol is different between like two countries. So if you take the mouse over to this resistor icon, you could see a little arrow, little arrowhead here. By clicking this, there are many variants of this same resistor. So these bunch of components from here to here, these are surface mount components. So if you Google surface the sizes, you could see a chart. So each size of resistor has a specific code, a metric code and imperial code. I'm using, so usually we are using these imperial codes. So for me, the tiniest I could solder by hand is this 0603 size resistors. Yeah. So these all are surface mount components, surface mount resistors. I'm going to go to the bottom section. There are these axial resistors. So these are the normal resistors we see day to day. We buy and we use them. They are readily available. So for those also there are a multitude of sizes. If you Google through hole resistor sizes, you could see there are bunch of sizes to choose from. Okay, so mostly we are using this quarter watt model, since we are not drawing a lot of current through this in our circuit. So I'm selecting oh sorry, since I told you we are going to use surface mount components, I'm selecting this 0805 variant, which is I shown you the size, right? Okay. This size. So it's not too large, not too big for soldering. Anyone who have at least some soldering experience could solder this without issue. So 0805 component is has a length of 2.1 millimeters and a width of 1.3 millimeters, so which is manageable. So I'm going to select this option, and bringing this onto our worksheet, and then we could by pressing this space we could rotate this component. So even after placing, you could click on this component and drag it wherever you want. And so this is the 4.K resistor. So initially it's like it's already named 1K. If that, we could click on here and go to component attribute area. We could enter the value. I mean, we refer this sheet to see whether which component needs to go where. So we already selected 0805 component. We don't need to change it. So again, we are going to rotate it by pressing space, and then we are placing it. So the value of this is 10 kilo ohms. So we are going to click on this and change this to 10 kilo. So then we have to connect the top pin of the 4.7K resistor to our supply, which we marked as VCC here. So we are going to this wiring tools toolbar and selecting this wire option, clicking on that. Then I'm zooming on, and then we are on the pin. The little circle appears. So make sure this circle appears, else like if we zoomed out, we might not connect it properly. If we connect it this way, it's not connected properly. So to connect it properly, we need to hover our mouse over the pin, and when this dot appears, we could click and click again when we need to end the wire. So I'm connecting this wire into VCC. Okay. So, and then we need to connect these two. So I'm not drawing this so the point which this 10K and 4.7K resistors connect, we are connecting it together, and we are connecting these two discharge pins. So once you selected this wire option, you don't need to select it over and over again, unless you change to another component. You could wire it without issue. Okay. So I'm not like drawing this pretty. So this just for like introducing you to tools. Another thing is like so usually in a project you might need to share your design. So when drawing the schematic, you have to draw it such that it's pleasing to see. I mean, the one who sees your PCB doesn't run away after seeing your PCB. But in this case, I'm just wiring as closer as possible to just introduce you for the tools. Okay, so the other end of this is going to connect this to this threshold pin. So this pin. So I'm clicking on this. And this threshold pin also connect to this trigger pin as well. Click here, go around the component, and connect this into the trigger pin. Okay. And after connecting to the trigger, we need to ground it using a 4.7 microfarad capacitor. So I think you know the symbols already. So this should be electrolytic capacitor by the look of the symbol. So to select capacitors, we could go to the 𝐸-ellipse menu and then scroll down, and then we could see the symbol. So we are going to select this electrolytic capacitor. So for this, we also have surface mount options as well as through hole options. Since it's easier to use a surface through hole capacitor here. So I'm choosing this one with the diameter of 3.0 millimeters. And I'm clicking on this. and I'm going to rotate so that positive terminal is facing this resistor. Then we could again click on this wire option and wire it. So this end we are going to connect to ground. So we could find ground here from this wiring tools menu. Could click on it and place anywhere we want. And again, you could select a wire and connect this. Okay, so this network we almost done. So now I'm focusing on this network. So for this we need this transistor BC547. So in our 𝐸𝐿EP in basic components we don't have transistors. We have some transistors, but it's not the transistor we need. This like another transistor set 2N3904. So if any component we need is not in this area, we are going to this library and we could type the component we need, BC547. We also getting bunch of components. So I'm selecting the one on the top and click on the place option. Now I'm placing it somewhere here. Okay. So this emitter is connected, emitter on the transistor is connected to the trigger pin. So I'm selecting a wire and okay. So the source pin is connected to collector pin is the pin which connected to the trigger. Emitter pin is connected to the ground pin. So this pin we are going to connect to the ground. Okay. And for the base, we have to connect 100 kilo ohm resistor. So we are going to our 𝐸𝐿EP and we already selected the surface mount component. I'm going to click on that and place nearby. And we are clicking on the resistor and change it to 100K. And again we connect this. Okay. So that connects to this another 10K resistor. We're getting another 10K resistor. So make sure to change the value as soon as you dropped off the component. Else, like if you do this at the end, it will be quite messy. Then I'm connecting this to here. And this connection to here. Okay. So we have another one component left. It's this IN4148 diode. Again, we are searching from this 𝐸𝐿EP window. Okay, there are diodes. There is a diode. We are searching. So we could right away click this drop down menu and select it. And then we could click on it and place this. So the positive end should be on bottom. So we are rotating into that orientation. Okay. So then we are again wiring to the pins. Okay. So from this area, another one component is left. It's this 100 microfarad capacitor. Okay. Oh, I almost forgot to change the value of this capacitor. This should be 4.7 microfarads. Okay. Yeah, again going to the 𝐸𝐿EB capacitor option, and from that we are selecting we are selecting this 3.0 millimeter capacitor. So I'm placing it here. So it should be orient the ground pin on the bottom. So I'm rotating it by pressing space and connecting it like this. Okay. So at the other end of the capacitor needs to connect to the 11th pin of this 4017 IC. So we could connect, we could draw a select wire and click on here and draw a line to the 11th pin, but we are not doing that because it's not pretty and it's not very well organized. So for stuff like that, we could use this option called net port. We could go to wiring tools and select this net port option, click on it. It's something like name, okay, so rather than connecting all the way from here to here, we could let's wire to this net port, and we could put a name let's put pin 11. Okay, so we could get another net port and place it on the 11th pin. Then we could wire it, and we, as long as the names are similar, so this net port is pin 11, we are clicking on this and renaming this to pin 11 as well. So the system automatically connect these two pins using these net ports. In PCB designings, complex designs, these net ports are used extensively to organize your circuit. Okay. So again, I'm iterating. This is not a very professional way to draw a schematic. I'm just doing this in ad hoc way, so you could learn what each tool does. Okay. So I'm going to show you a proper PCB drawing at the end of this session. Okay. So we connect Q3/2 pin 11. Okay, so we are done with this area. Also, we need to connect pin 8 and 4 of this 555 timer to our main supply. 8 we already connected. 4, click on here. Connect. Okay. And we have to also connect this pin number 1 to ground. Okay. And this output pin, which is pin 3 to pin 14 of our circuit. So there is a small issue in the this symbol we selected. The pins aren't in the order we need. Wait a second, I'm going to the library again. So I am selecting this option because the pin output of that IC is a little bit different. So as I said, there are like a lot of families of ICs. So you have to always check the data sheet whether the component we select matches the component actually we intended to use, or the component is same in the schematic we get or design, and the component we select from the library. So actually this pin 11 should be connected to Q9. Okay. So this output pin, pin number 3, should be connected to pin number 14, which is the clock pin of this one. So for this also, we could use this net port option. I'm placing a net port here. Again, this is not a very pretty way to design this PCB. I'm just teaching you the tools. So this is label it as out. I'm connecting this to out. Okay. So I'm again getting the net port, and see it's automatically change the label. So we need to rename it. Then we could connect it to the clock pin. Okay. So this 555 portion is done. We now have to wire this 4017 IC portion. Okay. So I'm going to rotate this IC a bit. I'm selecting. You could select any area and press space, so the whole thing gonna rotate. Okay. So now we could directly connect the resistors. Sorry, directly connect the LED. Okay. So in this night rider circuit, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 LEDs. Okay. So to get an LED, so LED is a very basic component. So we could assume it should be in this 𝐸𝐿EB since it's a common component. So we are going to 𝐸𝐿EB and scroll down, and there is the LED. So even for LEDs, there are these surface mount options as well as through hole options. So for this, I'm using this 3mm LED, a red one, because red is the color of a Knight Rider circuit as the main color of it. And we're selecting it, and then we click on this and placing on this. Okay, so we need 1, 2, 3, 5, 4, 6, okay, 9 LEDs. So we could click on the here and place on here, like that takes time. We could use there are a bunch of options. There is this option called distribute horizontally. This advanced option. We could click on this. Okay, just copy this. We could use normal shortcuts we used in other softwares, Control-C, Control-V, and Control-C, Control-V. Then we could select all 3 of these. Copy here. So you could see we are running out of space. So we could click on here and increase the space. Okay. Then we are putting another 3 LED copies. Okay. So we could like change this name. So we could pack everything together, but let's don't do that at the moment. Okay. So we need to connect LEDs from pin number 1 to pin number 10, excluding pin number 8. Okay. So first LED should be connected to pin number 3. Pin number 3 means Q0. The second LED Q1. So although these wires go like overlaps each other, if we like when drawing the line, if we do not click on this other wire, it won't connect, so it won't short. And then Q2. And then Q3. Then Q4. Q4 is on the other side. And Q3, Q4, then Q5. You could, I mean, the scroll wheel is very useful. Okay, mistake. You should like clear away from pins if they might, else they might short. You could use the scroll wheel to zoom in and out. So it's easier to place the wire in the correct place. And then Q6. Okay. And then we ground these pins through 330 ohm or 470 ohm resistor. So we are going to select the surface mount resistor for that asset. Okay. So after the resistor, I could place a ground pin and wire the resistor to the ground. So we are done with this portion of the circuit, and we also done with this portion of the circuit as well. So again, we should not forget to change the value of the resistor. So this should be 470 ohms. Sorry, 470 ohms. Okay. So, and then we also need to wire our power pins, VDD pin 16 into VCC and VSS pin into ground. Okay. So only remaining pins are these pins. Go into our sheet. So we have to wire pin number 11. Okay, we already wired that. Pin number 13 and 15, which means clock and inhibit pins. These pins to ground as well. I mean, it's advised to use these net ports and ground symbols, so we don't need to wire a wire all the way from here to here. But for this circuit, I'm going to wire it anyways. Okay. And then the C out pin, we don't need to connect to anything. So if I think anyone had actually designed night rider circuit know, like if you need to increase the count of LEDs more than 9, if you need to, let's say, use 18 LEDs, you could chain 2 of these CD4017 together and do that. Okay. So we have done with the schematic. So it's always good to double check it. So another one thing is missing, port to supply power. Okay. So we could go to eLib and select this pin connector, okay, which has a pitch of 2.45 millimeters between the pins. Select that and place it here. So I'm going to connect VCC and ground to this port. So the user could connect a battery or a power supply to here, and these net ports will supply the power and ground to the required parts of the circuit. Okay. Afterwards, we could press Ctrl S. So if we go to the project option, in our project, which is SLTC_SIRC, we could see our sheet saved. Again, I need to reiterate, this is not the pretty way to draw the circuit. Just I have drawn the circuit this way so you could get an idea about the tools. Okay. So there are pins which aren't connected. Okay. So those pins, we have to use this symbol, which called this no connect flag. You have to click on this and click on the component. So there is only 2 pins we don't use for the circuit. The C out pin of this CD4017 as well as C out pin of NE555 timer. So we are going to close it and save it again. Okay, it's better to recheck the circuit, so I'm not going to do that. And then afterwards you could, so now we are done with the designing of our schematic. Now we are going to turn this schematic into a PCB. So this is just a electrical drawing basically, which shows which component connects where. But actually to output a PCB, we need to draw it such that the manufacturer could manufacture it, such that it represents the real world layout of the PCB. To do that, after finishing and saving our original worksheet, we could click on design and press convert schematic to PCB. Okay, I'm going to click on this and then it loads, and then a black screen emerges. Okay, so there is this window comes up. Using this, we could select the dimensions of the PCB. Okay. So first we have to specify the units of the PCB. So basically there are mainly 2 units. So we don't use meters or centimeters in PCBs because those are large measurements compared to a PCB. I mean, in Sri Lanka and European countries, Australia, they use this metric system, which is in millimeters. Or if you are designing your PCB for American clients, you should use mil. Mil means I think 72 mil is a amount which comes when we divide the inch into 72. So it's better to use millimeters, okay, because most of the production houses, manufacturers use this metric system. And then we have to specify how many copper layers are on the board. So we could go up to like 34 layers or one layer. So if we are printing PCBs at home, we could use one layer, but it's better to use 2 layers if we are sending this to manufacturer. So I have shown you a picture last week where like traffic is a regular vehicle traffic is reduced by using overlapping intersections. So likewise, using more layers, we could connect components using less space. So I mean, the mobile phones, motherboards, stuff like those have 6, 10, 14, like many layers like that. Okay, and then we have to select this board outline. So board outline means the shape of the board actually. So we could make it a rectangle or a circle or a round rectangle. You have seen, like, if you disassembled any components, there are like PCBs in various shapes and sizes. So you could select any shape. So sometimes the shapes and sizes you look for might not be in here. So if you design an actual product, say you are designing again a smartwatch, so the product designer of your team, the CAD designer of your team might have already have come up with the sizes of the watch, and as a PCB designer, you have to adhere to that physical constraints, physical sizes. The other members who actually design the physical structure of your product and design the PCB accordingly. So since we don't have something like that, we could, in this case, we could select any size we want. So I mean, there are ways which we could create like different shapes and sizes. If you need to make this looks like a star, you could do that as well. So I'm not going to cover that in this lecture. So for this, we are going to use a rectangular circuit, and we could specify the start and end positions, starting coordinates. So this doesn't matter, but in this application, but we have to pay attention to this width and height. So maybe width, let's choose something like 60 millimeters, which is 6 centimeters, and width something like 3 centimeters. Then we press apply. Okay. So you could see, okay, you could see the components we selected. So these are like tabs in a web browser. You could switch between the schematic and the PCB. So in the schematic, the components are labeled like standard electrical symbols. But in the PCB tab, you could see your components in the actual shapes and sizes. Okay. So again, there are a bunch of tools. If we check the schematic, there are tools specifically that could be used for wiring the schematic. And if you switch to PCB view, there are options which you could select various components or various options which could be used to design the physical layer. Okay. So there's another important toolbar which called layers and objects. So I told you like there are multiple layers in a PCB. So in this case, we selected a PCB with 2 copper layers. So if anyone used Photoshop or Illustrator, you might know about layers. So the layers in this are same. So although we have 2 copper layers, there are a bunch of layers which defines the color of the PCB and what's printed on the PCB, as in the words, and where we need to drill holes, where we need to cut the board. Okay, so mainly we need to pay attention to this top layer and bottom layer and board outline layer. So there is this color. So in this window, anything which is in red color is belong to top layer. Anything is see, these are on top layer. Anything which belongs to bottom layer is on blue color. So at the moment we don't have anything on the bottom layer, so there's nothing in blue. And then if we go to this board outline layer, you could see this pink color is the color we have like that defines the boundaries of the PCB. As you could, I think you could remember, we entered 60 centimeters by 30 area. So this square represents that area. So we have to fit our circuit inside this. I mean, we could change it later by like dragging on these dots. So I'm not going to use that. We might need to increase the size of the PCB. Let's see how it goes. Okay. Let's maybe increase the length a little bit to accommodate. Okay, somewhere this. Okay. So first, I mean, there are ways to like place the components, like depending on the application, you need to place one set of components first, and there is a priority. But again, for this, I'm not using any standard ways. I'm just teaching you the tools. So I'm going to place our IC, the main IC 4070, maybe in the middle of the board. Okay. So you could see these lines. These are called rat lines. Okay. It's on this light blue color. Okay. So this represent which pin needs to connect where. So basically, those lines represent the lines we drawn here. Okay, but the pins aren't connected yet. I mean, these lines are just for reference. Okay, first we have to place the components in the board. So depending on the application, again, you have to place your components in certain ways. Again, for this, I'm not using those. I'm just placing it wherever I want. So first, I'm going to get this LED number 1 and placing it here, and LED number 2. I'm just bringing this into the board. I'm not arranging it because we could arrange them later. LED 4, LED 5, LED 6, 7, 8, and LED 9. Okay. So there are a bunch of options which we could use to arrange these things. I'm going to select these and select this option, distribute vertically. Use this align bottom option. Select align horizontal centers. Or we could use this distribute array option to distribute the matrix. Okay. So it automatically distributes it. Okay, and I'm doing it again. So undoing the thing. Okay. So we initially placed the components not exact places, just somewhat in order. And then we are going to select them, and we are going to the distribute array option. I mean, there are like hundreds of options you could choose for. I'm not going into the details. So I'm just selecting distribute array. There are many options you could use to arrange your components automatically rather than placing it one by one. And I'm not changing anything. Okay. Press cancel. And then I'm dragging our components to here. Okay. So it's better to look at these rat lines. So see, I mean, if we had this LED rotated this way, this line should go here to here. So the easier way, shortest path is when the LED is oriented this way. So even for the IC, if our LED is oriented in the opposite side, the wire has to go over a long way from the LED to the IC or other component. So these rat lines are mainly for reference, so we could place in the correct orientation. Okay, and then we are going to place this resistor maybe somewhere. In this case also, we could click on component and rotate it. So again, I'm not placing this in any order. I'm just placing it. And there are techniques to check where we need to place the component exactly. So I'm placing this here. Again, there is no one single way to do this. It's after this point, it's like art. You could place it as you like. But one thing I need to mention, these connectors which a user connects to the external world should be near the edge of the board, else it's harder to connect. Okay, I am placing LEDs close to edge. So it's more visible inside the area populated with all these components. We could like rotate around, place the component around, and see which orientation has the least overlaps. So as you could see, like we could actually shrink the size of the board by placing this components. But again, another thing I need to mention is like when placing resistors and components, it's better to place it in a single orientation. So it's better to, it's easier to solder afterwards. So we should not keep like components too close, else it might give errors. Okay. So anyways, like circuit looks like a junk. Don't mind it. I just need to teach you the tools. Okay. So I roughly place the components. There are more like good ways to place the components. Okay. So okay. Let's say we are done with we are happy with the placement of the component. Then the major step is we have to wire the components, and we have to actually so there are those red lines, net lines, which shows you which pin needs to connect to which pin, but there isn't an actual connection being made yet. Okay, so for that we could use this track option. It's the icon is similar to the wire option because both of them do similar things. We click on that and then click on the layer which we need to draw this on. So since these resistors and all those surface mount components are on top layer, I am selecting the top layer, and then we have to pay a little bit of attention to after clicking on this track, the attribute panel changes. So one of the most important thing is this routing width option. There are like other important options, but in this context, I am focusing on this routing width. As you know, I mean, let's take a wire. Okay, if a wire has a larger diameter, it could carry a lot of current. Okay, you know the formula to calculate the resistance. So when the diameter of a wire or a conductor increases, the resistance will be lower. So it could carry more current. Okay, so the tracks we draw between components are similar to wires. Since we couldn't control the thickness, I mean, we have a choice when manufacturing, but yeah, I'm not going to focus on that. So we have to play around with the width of the conductor. Okay, so since we treat this as a 2D object, so I mean, there are many ways we could calculate this required routing width. There are sites which could calculate routing widths. You could search on Google. There are like dozens of tools. Okay. So you could specify how much current we need to go through the conductor. So it's a very little circuit. Let's use like, let's see, this only uses 0.5 amperes. Okay. And the thickness of the PCB. So this is based on the manufacturer. I'm going to show you how a PCB, we give these documents to a manufacturer to actually manufacture the PCB. So the manufacturer I'm going to introduce you has two options. One, ounces per feet, square feet thickness, and 2 ounces per square feet. So the cheapest option is 1 ounces per square feet. We select this, and automatically this calculates the required minimum trace width. This is on mil, to change to millimeters. So as long as trace is more than 0.0115 millimeters, yeah, okay. So there are like a lot of tools like how much is the increase of the heat and stuff like that. We are not going to talk about that in this. So let's use, since we have space on the board, let's use something like 0.3. I mean, if you are designing a circuit which carries power, we have to pay very close attention to this. Else, I mean, a circuit might contain areas, components which needs to flow large amounts of current, and there should the other section of that same PCB, there might be areas which doesn't need much of a current. So on those areas, we need to make the tracks smaller, and the other areas we have to make the tracks bigger. So anytime you could change it before drawing your route or a trace. I mean, even after drawing that, you could click on the line and change it as well. So firstly, I'm going to connect this to this. So it automatically snaps. We could click on the component, and this rat line shows us the direction we need to move our mouse. And we could go on top of the component, and it locks the mouse, and we could click on it. So that blue line disappears and actual connection is made. And then we could, so I'm going to wire this quickly. So, okay. So I'm using a similar width for everything since we don't carrying a lot of currents through the circuit. I mean, there are like, and in universities, there are complete modules which dedicated to teaching PCB design. So it's something which we cannot do in few hours. So yeah, this is just the outline. You could learn it further, and I'm going to show you how you could further your knowledge on PCB designing. Okay, likewise. Okay, so in this example, there is a conductor going from C1 to R5. Okay, in this red color. Red color means this top layer. But we need to connect this D1, this pad into R3 resistor. So there is an overlap. Okay, if we connect this, so if we click on the wire and drag, the line doesn't move after this point, because if we move on top of this, there could be a short circuit. So another way we could go around this component and come here, but that's also a little bit inefficient, since we have the option to use 2 layers. We could so go close to the boundary here, and there are 2 shortcuts, B for bottom layer, T for top layer. If we click on somewhere and press B, it now the line is blue. That means we are drawing in the bottom layer. Okay, so it come here, and then this R3 component, as I showed you before, this surface mount component, this is on the top layer. So we have to come back to the top layer. So to that we could press T again, then the line is red, could connect it. So we are going under this line and connect here. Okay. Okay. Likewise, we could use many techniques to connect, draw traces between components in the shortest, using shortest length. I mean, we have to select the closest path, else there might be power loss, there might be increase in noise, likewise. Okay, so we could go on and wire the whole thing together, but I'm going to show you a little trick. So in when in professional circuits, there is a way, I mean, to do this wiring automatically. Okay, so that's called the auto router. What we do is the routing. What we did was routing. There's an auto router, but again a warning: in professional circuits, we don't use routing, auto routing very much, because when the computer takes over the routing, it might messes up things, and there might be more better ways to connect. Like still, the computers are a little bit, can't think like human, so they might not go according to the design principles. Like we going to we are going to implement on the circuit. It might not scale the widths of the routes accordingly, paths accordingly. So, and yeah, there are a lot of problems like that. Sometimes even like PCB should looks good as well. So if you take a PCB of a consumer product, let's take a motherboard of a computer. So it's the layout is laid such that it's very organized. So if you do auto routing, if you let the computer to route to a circuit, it might not do that. So if you are designing a professional circuit, you have to it's advised to route manually. But for hobby context, we could use the auto router. So okay, we could keep it like that and go to this route option, and there is this auto route option, and then there's sub option called auto route. When you click this, there's an option appears. Okay, so you could display the routing process by clicking on this tick, and then you could select this routing is gonna processed in the cloud or our local machine, and then we could specify which layers we need to route and which layers, which nets, which paths we need to skip. So I'm not going to like details on this menu as well, since we are out of time, and we are just pressing run. Okay. So it takes some time. It uploads this into their cloud server. So since a lot of people doing this simultaneously, there might be thousands of people requesting this auto router. So since this service is given for us free of cost, we have to wait for a turn until they give us space in their server. So we could this program could send the file and do the routing. So we have to wait for a while. Sometimes in peak times, this auto router couldn't run the auto routing on the cloud. See, due to the limitations of router server resources, multiple routers executing concurrently are not supported. Please try again later or do it manually. So yeah, let's try again if we could auto route this. See, it auto routed it quickly. So it completed 100%. Sometimes when the computer can't decide the route it fully, it shows an error like a percentage and number of failed connections. So in this, we are done. No issues. You could press OK. So it's somewhat wired correctly. I mean, if you have some experience, you could see like there are better ways we could have connected, like these LEDs could have connected more aesthetically pleasing way. But for the context of this workshop, it's fine. Again, if you are doing this professionally, don't use the auto router.
Recording in
And there's a
progress.
special option where we could visualize it on 3D space, where we could see how the circuit gonna looks like after finishing. You could press the 3D view. See, we could rotate it, see how the connections are made, how it looks like, and we could change the board color, red color. Use black color because the Knight Rider car is black. Okay, so we could see our surface mount components like this on the surface, and the through hole components go all the way to the bottom. Okay. So we could close this view, and go back to our circuit. Again, there are like many ways we could many more standards we should follow in designing PCBs in professional as well as hobby application. But given the time, we are not going to go on to those topics in deep level. But if you need to learn like advanced options, how to like actually design a PCB that goes into a critical product, you could join for our full-time courses from IEEE.lk. So you could. I'm going to do a little bit of introduction. So you could go to IEEE.lk. We'll be sending a link to register for our courses. Those are gonna happen in weekends where we could you could participate regardless of your daytime work. So then you could scroll down. There are several courses you could select from, and as we told in the last lecture, for the participants of the workshop series, going to get we offer discounts for our courses. So say if you need to learn basic programming with Arduino, you could select this course. There's this advanced course and beginner course for robotics called Step into Robotics. And if you we cover our courses in multiple languages, and this especially, like if you need to learn how to design your PCBs professionally, you could do this course. You could go to our website. We will be putting a link on your WhatsApp group, so you could register. So you could click on that apply now. So this course is taught by an expert of PCB designing who have designed PCBs for both national and international customers, as well as even military. So he'll touch on those advanced stuff, those standards you need to follow in great detail. So there are two courses you could choose. One is basic course, which covers basics you could use to design hobby level circuits, PCBs. And there is 2-month advanced course where you could learn to design professional level circuits. So more info will be shared on your WhatsApp groups. As well as they will post a link on your WhatsApp group to register for these courses. Okay, so back to the lesson. So we finished designing our PCB, and so we are running out of time. So we are going to cover the next steps where we take this PCB layout to a manufacturer, or how we are going to manufacture this ourselves at home. Those topics we are going to cover on the next session. Okay. So there is another thing I need to remember. So we are going to give a small assignment for you to complete. So based on that assignment and a quiz which is going to be held on next week, you are going to get a certificate as well as large 20%, 25% discounts for our courses as well. Yeah, I think it's time to end the lecture for today. Again, like if you have any queries, please forward it through the link the moderators provided. So we'll continue on the next week to finish this circuit, as well as learning a brief introduction how to actually manufacture this circuit. Okay, thank you very much. Back to you, moderators.
Thank you, sir, for showing us how to design a PCB. But tonight, in addition to the questions from the forum, we would like to invite our participants to unmute themselves and ask any other questions that they might have. We will get to this after we finish clarifying the doubts that were raised in the Q&A forum, though. So I request that our viewers who have questions, please raise their hands in the participants list. You will get the opportunity shortly. And now, moving on to the questions from the forum, will you be willing to answer them first, sir?
Yeah.
Thank you, sir. So the first question is, are there any disadvantages of using small-sized circuit components apart from difficulties during soldering? And what are the techniques used to solder them?
Okay. So the main difficulties, one is if you going to assemble it manually, so it's little bit difficult. So I mean, by when you get the experience on soldering, you could solder most of the components. But there are some components which need special tools like hot air guns and etc. But the thing with surface mount components, those tiny components are like it's easier. Like it takes less space. It's better if we could reduce the space of our PCB, as well as usually, like for if you are making your product by thousands and thousands, the assembly process will be automated. I will show you a video how those machines called pick and place machines. Basically, those are like robots which pick and place components onto the correct places. So for those machines, it's very easier to use those small assembly components rather than through-hole components. And another disadvantage of those small components are the availability. Sometimes surface mount components aren't available in the country. Yeah.
Thank you, sir. The next question is, how can we design the circuit that was in the picture you shared? How can we decide to clarify the question? The person who asked the question wants to know how can we decide which components with which values to use? Okay,
that's based on your electronic knowledge. Okay, so I could have taught you that, but the context is of this course is designing the PCB. So basically, there are multiple ways. One way is you could start from ground up. You could identify the requirements and identify the components which satisfy those requirements, and then look at the data sheets of those components. And in those data sheets, there are reference designs. You should refer them and select components. And some components are based on the electrical characteristics we need to we need to obtain from the circuit. And there is a lot of things goes inside. And another is you could look around internet. There are like thousands and thousands of and for an application there are many schematics you could find. But and it's like news. There are fake ones as well as legit ones. You have to filter it out. You could use designs from other sources as well. Yeah.
Thank you, sir. But before we move on to the third question, I have another small announcement to make. Our viewers can also ask their questions in Sinhala or in Yes, in either Sinhala or in English. Sir, can we move on to the next question?
Yeah.
Where can we get all the components that we would need for a circuit that we design?
Yeah. So I'm going to teach you that how to source components. A brief introduction. That's, I mean, supply chain is another huge area. So I'm going to give a little introduction for that as well. Another thing I forgot to tell you, like when you are designing the PCB, when you are selecting the components, you have to check the availability as well. So availability of the component. I'm going to talk about that in great detail. And there is a huge issue in the world these days. Many car companies stopped manufacturing some models of cars because of this chip shortage. I'm going to explain that in next session.
So, the next question is, why do capacitors have three kinds of symbols? Does that mean we have three different types of capacitors? And how do we know which type of capacitor to use?
Okay, so mainly there are like two types of capacitors. Okay, mainly, and there are like other categories as well. Mainly there are electrolytic capacitors and normal normal ceramic tantalum capacitors. So the signals, symbols of those are a little bit different, as well as signals differ depending on the country. As I shown you, there are different symbols which is used in USA and the rest of the world.
Thank you, sir. The next question is, when we are ordering the PCB, how can we get the PCB? Can we get the PCB as components soldered PCB? I'm not sure sir, what this question exactly means.
Yeah, that means so there is a thing called the PCB assembly. So there are services in Sri Lanka as well as in China and other countries which if you send them PCB and the components, they'll solder it. They mostly using machines. So if you are building some product units more than maybe 100, you should go for those options.
The next question sir, is something that you answered during the first session. What is the relationship between Arduino and PCB?
Okay, so that's it's not something that could compare. Okay, so I answered it last week. Next question.
Thank you, sir. Can we use Arduino for the invention project that we will have to submit later on?
Yeah, no problem. Would use.
Thank you, sir. The next question is, when the colors change on the PCB, what will happen to quantities such as power consumption and working speed?
Color doesn't factor into like power consumption unless like it's a very sensitive circuit or something. But generally, color doesn't matter. Color only matters. So like green color, I think many PCBs you see every day are green color. So green color PCBs are cheaper. So the color is basically only the like outer parts of the PCB color. So like other colors might cost more and might take more time to produce. Yeah, I'm going to like I haven't talked about other layers, so I'm going to give a little introduction for that in the next manufacturing session as well.
Thank you, sir. The next question goes that this viewer has apparently used Tinkercad before, and they want to know what are the differences between Tinkercad circuits and PCB designs. Sir.
So Tinkercad is basically a easier way to simulate circuits. You could draw circuits and check whether they work. Okay. So to produce that circuit, to take that the circuit and mass produce that circuit, build a proper circuit which is robust and durable, we have to design a PCB. So first, we could use something like a Tinkercad. I told you, like, when coming up with the schematic circuit diagram, we could use those simulation tools such as those Tinkercad and Proteus, Multisim. There are like many tools. You could simulate the circuit, and then after you finalize the design, then you could move into this PCB designing and producing.
Thank you, sir. The next question is, they're asking what is the difference between between a wire and a bus in a schematic drawing?
Okay, so wire is like a connection between basically two places, okay, which not typically shared. So again, like if we go to a vehicle analogy, wire is like a car, bus is like a bus, which many people connects to and take advantage of. Basically, bus means a line or a connection which shared among a lot of like components. Wire is just a connection between two or like 2-3 points. I mean, that's a little bit interchangeable sometimes, but bus is like a common section for section which multitude of components connected.
Thank you, sir. The next question is, can ECEDU be used on a mobile phone?
I haven't tried. The screen size is a little bit like we have to have a larger screen size, but using a tab, it's definitely possible and might be easier. Like if you have touch screen, it's a little bit easier to design the PCB. Yeah, probably use a tab. It's better. Mobile phone, if you are really savvy enough, and you could do it, no problem, since it's cloud.
So the next question, can we print the circuit at our home without sending it to a company? And if we can, how can we do that?
Yeah. So the first thing is you have to design. So we took in routing this circuit, we took the liberty of using like both layers without any hesitation. So if we are producing this circuit ourselves, we have to have like most of the connections, most of the wires, most of the routes on a single layer. Else it's really hard to print. I have print several times. Sometimes it's successful, but it's really hard to. So basically, the thing is, if you are printing your circuit at home, try to design the circuit in a single layer. So like if there is unavoidable scenarios which you have to go on top of connections, you could use a jump wire.
Thank you, sir. The next question is, what is a stencil in a PCB ordering?
Okay, stencil means that I am going to answer next week, next session. Stencil is basically stencil, which used to coat and dispense or spread this solder paste, this solder lead we use to solder components into required pads. I'm going to answer it next week.
Thank you, sir. The next question is, if we can do the same thing that you showed us on ECEDU using Proteus software.
Yeah, definitely possible. Proteus. I began my PC design like many years before using Proteus. The issue with Proteus is some of the newer parts aren't available in the library. I mean, you could add parts to the library and create new footprints. It's a bit problematic. So yeah, I'm using ZDA and KiCad these days.
Thank you, sir, for answering those questions for us. Now, I would like to invite our first participant, Mr. Dinesh, to ask their first question.
Hello.
දිනේෂ් අපිට අහනවා සර්ගෙන් වගේ ප්‍රශ්න අහන්න.
මට ප්‍රශ්න දෙකක් තියෙනවා. එකක් තමයි මේ PCB එකේ දැන් අපි ප්‍රැක්ටිකල් එක කරේ 2 layer PCB එක. අපි දැනට මේ මාකට් එකේ තියෙන්නේ single layer copper board තමයි ගන්න. ඉතින් අපිට මේ software එකේ කරන්න බැරිද? අනිත් පැත්තේ තමයි අපි අර මෙටල් හරින copper area එක තියෙනවා. අමුතර area එක. ඒක අපිට ගේට්ට යවන්න නැතුව රවුන්ඩ් එකට ඉතුරු කරගන්න කොහොමද මේ software එක? feel කරන්න.
මේ දැන් පළවෙනි ප්‍රශ්නේ කිව්වොත් එහෙම මේ අර ඩුවල් ලේයර් කොපර් බෝඩ් මෙහි තියෙනවා. ඔතන මේ ලොකුම ප්‍රශ්නේ අපිට මේ අර ලේයර් දෙකක් මේව කරද්දී අර අපි අර ටෝන ට්‍රාන්ස්ෆර් එක කරද්දී කොලේ ඉඳලා කොපර් බෝඩ් එකට අලයින් කරන්න ටිකක් අමාරුයි. එකපාරක් මම කරා මේ ඒකේ බෝඩ් එකේ දෙපැත්තේ සිදුරු දෙකක් ගහලා ඒකින් අලයින් කරා. ඒ වගේ කරන්න පුළුවන්. මේකේ අපි සිංගල් මේ software එක use කරලා දිනවා නම් අපිට මේ අර auto route මේ කියන්නේ manual route කරන එක තමයි හොඳ මේ කියන්නේ අපි නිල් පාට වයස කියන්නේ bottom layer එක අඩු වෙන්න අර අත්‍යවශ්‍යම මේකට ඇරෙන්න එතකොට ඒවා jumper wires විදියට දාන්න පුළුවන් auto router එක දුන්නත් අපිට මේ අර option එකක් තියෙනවා මේ auto routing ගියාට පස්සේ එක layer එකක් විතරක් route කරන්න එක ඊට පස්සේ ground fill එක මම අද කතා කරන්නේ නැහැ මේ මම මේක ලබන සතියේ කතා කරනම් මේ manufacturing යවද්දී මේ ඒක මෙතන ඔයාලට බලාගන්න පුළුවන් මම PCB tools option එකේ තියෙනවා මේ copper area කියලා එක. E තමයි මේ shortcut එක. ඒක press කරලා අපි වටේට රවුමක් ඇඳපු ගමන් මේ copper area copper මේ පෝ එකක් වැටෙනවා.
And next we invite Mr. Damruan to ask their question. Mr. Damruan?
Yes, am I audible?
Yes, you are. You may now ask the question.
Yes, okay. Sir, can we add Arduino Nano or Arduino something development board with this design?
Yeah. So I'm going to show you that next week. Remind me, like put a message on the.
Okay. Sir, and also, can we simulate the design?
You could simulate
With this
in
software?
this. Yeah. The circuits which doesn't have codes, firmware. Like if you can't simulate Arduinos through this, like you do in Tinkercad or Proteus. But simulations with basic components, it's possible.
So can we do it with Proteus software? I mean, so my designs with codes?
Yeah. There is a like you could add the component library for Arduino, and then you could export it. Yeah, there is plenty of tutorials how to do that, how to simulate it. Or you could use Tinkercad. It's like integrated everything together. Could directly code on that.
Okay, sir. Thank you.
And next, Mr. Tusit Herath, if you would please ask your question.
Thank you.
Oh, Mr. Tusit, අපිට
සර් මේ මට දැනගන්න පුළුවන්ද අපි දැන් ඔය ඩිසයින් එක කරාට පස්සේ ඔතන අර ස්කීමැටික් ඩයග්‍රෑම් එකයි ඊට පස්සේ මේ PCB ඩිසයින් එකයි දෙකම තියෙනවනේ අපිට විදිහක් තියෙනවද ඕක මේ සේව් කරගන්න ඒ කියන්නේ අපි හිතමු PDF එකක් විදිහට හරි ඉමේජ් එකක් විදිහට හරි මේ ඩවුන්ලෝඩ් කරගෙන අපිට print කරගන්න වගේ කරගන්න
ඔයාට මේ අපි දැන් ස්කීමැටික් එක නම් ස්කීමැටික් එකට ගියා ඒ ටැබ් එකට ගිහිල්ලා ෆයිල් ගිහිල්ලා මේ print option එකක් තියෙනවා නැත්නම් export කියලා option එකක් තියෙනවා ඒකේ PDF එකක් විදිහට export කරන්න පුළුවන් file export PDF දෙකටම පුළුවන් මේ schematic එක PCB එකට දෙකට
හරි සර් ඒක මේ 3D එකක් පුළුවන් සර්
3D එක නම් එහෙම save කරන්න option එකක් කියන්නේ 3D object එකක් විදිහට save කරන්න බෑ ඒක තමයි මේ ECDI professional වැඩ වලට පාවිච්චි කරන තමයි LTM KiCad එහෙම ගත්තට පස්සේ ඕක පුළුවන් අපිට CAD program එකට SolidWorks Fusion 365 CAD program එකට export කරන්න. මේකේ ටිකක් ඒක අමාරුයි. මේ ඒක නිසා අපි 3D view එකේ එක්ක screenshot එකක් ගහගෙන එහෙම එකක් තමයි කරන්න පුළුවන්.
හරි සර් thank you sir.
Mr. Tisarutpala, it's your turn now.
සර් මේ අපිට මේ සර්කිට් එක මේ සිමියුලේට් කරලා බලන්න පුළුවන්ද මේ වැඩ කරනවද කියලා එහෙම පොඩ්ඩක් ඒක ගැන මට කියන්න.
ඔව් මේක නම් මේ කම්පොනන්ට් එක මෙහෙම උතන සිමියුලේට් ECDA වල සිමියුලේට් කරන්න පුළුවන් නේද කියලා කියන්න අමාරුයි. මොකද මේ ඒ කම්පොනන්ට් දැන් IC එකක් ගත්තොත් එහෙම කම්ප්ලෙක්ස් බිහේවියර් එකක් නේ තියෙන්නේ. ඒ බිහේවියර් එක මේගොල්ලන්ගේ ලයිබ්‍රරි එකේ තියෙන මේ සිමියුලේට් කරන්න පුළුවන්. අවුලක් නැහැ. මේ මම මේකේ ලොකුවට IC තියෙන ඒවා සිමියුලේට් කරන්න නම් ගොඩක් වෙලාවට සිමියුලේට් කරද්දි මේ Proteus තමයි යූස් කරන්නේ. Proteus වල පුළුවන් මේක 40 දාලා.
thank you sir.
Next, Mr. Namidu Ratnayaka.
Sir, excuse me sir, ලංකාවේ තියෙනවද PCB print කරන දැන්?
PCB single layer print කරන දැන් තියෙනවා. 2 layer print කරන දැන් තියෙනවා කියලා කියනවා. ඒවා මේ ඇත්තටම ලංකාවේ print කරනවද චයිනාවේ print කරනවද කියලා sure නැහැ. single layer නම් print කරන දැන් තියෙනවා. මේ මම business වල නම් කියනට හරියට දන්නේ නැහැ. කොහමරි ගාල්ලේ වගේ නම් තියෙනවා. වෙන මතක නැහැ. කොළඹ වගේ නම් නිලබර කියලා තියෙනවා කඩුවෙල ප්ලේස් එකක්. ඒක මේ හොඳට මේ සිංගල් ලේයර් බෝඩ්ස් ප්‍රොඩක්ට් ක්වොලිටි එක print කරලා දෙනවා. ඒ වගේම මේ 2 layer ගත්තොත් එimhe Aptinex ලා print කරනවා. ලංකාවේ print කරනවත් දන්නේ නැහැ. කොහොමවත් මේ ඔයා කියන්නේ දැන් ඇත්තටම මේ මම නම් පෞද්ගලිකව අවුරුදු දෙකකින් විතර මේ සර්කිට්ස් අපි print කරගත්තේ නැහැ. මොකද මේ දැන් ඔය courier services එහෙම තියෙනවා මේ අපිට සතියෙන් විතර PCB එක print කරලා ගෙන්න ගන්න පොඩි ගානකට.
Okay sir, thank you.
Hirun Mitsara.
සමහර වෙනද?
ඔව්.
මේ අපිට මේ අර රෙසිස්ටර්ස් තියෙන මේවා මේ අපිට අර PCB වලදී අර අපිට මේ සෝල්ඩර් කරන්න බැරි නිසා ඒගොල්ලෝ සෝල්ඩර් කරලා දෙනවද ඔයගේ රෙසිස්ටර්?
ඔව් මම ඔයාලට සෝල්ඩර් ගන්න බැරි නම් හොඳම මේක තමයි මේවා වෙන මම මේ surface mount component පාවිච්චි කරලා පොඩ්ඩක් නිකන් අර පෙන්නන්න. ඔයාලට through hole component use කරන්න පුළුවන්. surface mount components use කරන ඕනම නම් මේ ඒගොල්ලන්ගේ solder කරලා ගත්තා. ඒක ටිකක් ගාන නම් ටිකක් වැඩි. ඒක ඊට වඩා ලේසි මේ අතින් ඔය කියන්නේ අතරම මේ පැක් දෙකක් යද්දි මේ හුරු වෙන්න පුළුවන් 0805 component එකේ පාසන්න බඩු ටික හොඳ tweezer එකකුයි හොඳ බෞද්ධ එකකුයි අතන අවුලක් නැහැ.
අනිත් එක මේ ඒකෙම ඒ විදිහටම පුළුවන්ද දැන් ඒ හදපු දැන් ඩිසයින් එකෙන්ම අපිට පුළුවන්ද රෙසිස්ටර්ස් අපිට ඕන විදිහට සෝල්ඩර් කරන්න නැත්නම් ඒකට වෙනම මේ සයිම්බල්ස් පාවිච්චි කරනවා.
මොකද? ප්‍රශ්න කියන්නේ ආයි කියන්න පුළුවන්.
දැන් අර සර්ෆේස් රෙසිස්ටර්ස් මේ අපිට මේ කරන්න අමාරු නිසා දැන් අපිට සෝල්ඩර් කරන්න පුළුවන් විදිහට ඒක මේව කරගන්න පුළුවන්ද? හදාගන්න. ඒ කියන්නේ මේ ඒකේ සයිම්බල්ස් වලටම පුළුවන්ද?
ඔව් ඒ කියන්නේ දැන් ඔයාලට ගිහිල්ලා මේ මම ඒක ඔයාලට කියන්නේ අර ස්කීමැටික් එකට ගිහිල්ලා රෙසිස්ටර් එක ක්ලික් කරලා ඔයාලට පුළුවන් එයාගේ මේ ෆුට්ප්‍රින්ට් එක මාරු කරන්න. මම ඒක පුළුවන් වුණොත් කියලා දෙන්න නැත්නම් Google එකේ ගහනකො how to change the footprint of a component in ECDA කියලා. එතකොට ඒක component එක ක්ලික් කරලා අර attributes වල තියෙනවා මේ footprint කියලා option එක. ඒකෙන් පුළුවන් footprint එක change කරන්න. එතකොට change කරලා අපිට design ගිහිල්ලා update PCB දෙන්න පුළුවන්. එතකොට PCB එක update වෙනවා අර component එක.
Okay sir. Thank you.
And finally, Mr. Rukshan Chaturanga.
Sir, මම ඇහෙනවද? මම ඇහෙනවද? සර් මේ අපිට දැන් මේ ඕකේ දැන් අපි ඩිසයින් කරන PCB එක අපිට මේ PDF එකක් වගේ හරි මොකක් හරි එක ඩවුන්ලෝඩ් කරලා කියන අර ඒ කියන්නේ දැන් අපිට මේ ගානට ඒ කියන්නේ අපේ හරි සයිස් එකට අපි මේ සයිස් එකට අපි ඩවුන්ලෝඩ් කරලා අපිට print කරගන්න බැරිද සර් ලේසර් print out එකකින්
මේක ඔයා මේ ෆයිල් එක මම ඒ ටික කියන පොඩ ලබන සතිය කතා කරන්න එක්ස්පෝර්ට් ගිහලා මේ PDF එකක් විදිහට එක්ස්පෝර්ට් කරලා පස්සේ අර මේ true size එකට print කරලා ඊට පස්සේ printer එකෙන් print දෙද්දි මේ actual size කියලා option එකක් තියෙනවා ඒක දීලා print කරාට පස්සේ මේ අවුලක් වෙන්නේ නැහැ
අපි සර් දැන් හරි කියන්නේ excuse අපි සර් එතන දැන් මේ අර හරි මේ size එකට අපිට මේ ගන්න පුළුවන්ද මේකෙදි size එකටම අපිට PDF එක ගන්න පුළුවන්ද නැත්නම් PDF එක size එක විදිහට edit කරන්න පුළුවන්ද
නෑ PDF එක මෙයා size එක විදිහට export කරනවා. ඕකේ ලොකුම ප්‍රශ්නේ නෑ කොහෙන් හරි print කරන්න දුන්නාට පස්සේ මේ ඒගොල්ලෝ ඒ auto scale කරන්න ගිහිල්ලා මේ කා ගන්නවා. ඒක පොඩ්ඩක් කියලා මම පෙන්නන්න මේ ලබසති මේ කොහොමද මේ හරියට මේකක් export කරන්න කියලා.
හරි sir. Thank you sir.
Sir, it seems Hirun Mitsara has another question. Will you be willing to answer it for him, sir?
Yeah.
Hirun Mitsara, please ask your question.
Sir, අර 3D view එකේදී පෙන්වන sir මේ සමහර ඒවා තියෙනවා මේ ඒකටම solder කරලා වගේ දැන් ඒක ආදේශයෙන් ඒ විදිහටම තියලා මේ PCB එකට order දුන්නොත් එහෙම solder කරලා දෙනවද නැත්නම් අපි මෙහෙම මේක කියන්න ඕනද
solder කරලා ඒ විදිහට තමයි සාමාන්‍ය solder කරන්නේ චුටි වෙනස්කම් තියෙන පුළුවන් මේ solder කරලා ගෙනද යාර ප්‍රශ්න දෙන්න තියෙන solder කරලා ගෙන්නවට පස්සේ ගාන ටිකක් වැඩි
නෑ සර් 3D view එකේදී පෙන්වන නිකන් සේනම solder කරලා diode ඒවා මේ order කරොත් එහෙම එනවද නැත්නම් අපි එහෙම වෙනම anonym කරන්න ඕනද ඒගොල්ලොන්ට
වෙනම තියෙන option එකක් ඒ කියන්නේ anonym කරන්න එහෙම ඒ කියන්නේ part placement එක එහෙම දීලා ටිකක් ඒක වැඩි ටිකක් තියෙනවා මම බලන්න ලබන සතියේ ටික මේ පෙන්නන්න
Thank you, sir, for answering all of those questions for us.
Okay.
We really appreciate it, sir. And now there are a few more announcements, and I would like to hand the session over to Tharushi, my co-moderator, to take it from here.
Yes, Sonal. And thank you, sir, again for answering those questions for us. Now, I would like to remind everyone to mark your attendance by filling out the Google form that has been shared in the chat box. And there will be a quiz and an assignment next week. And for those who want to refer to this session again, we will be uploading the recording of this session to our YouTube channel and the link will be shared with you. And also, our third session will be held on the 27th of September. And it will be a great opportunity to learn more about PCB designing and expand your knowledge. So we expect your presence on that day too. Moving on, the virtual exhibition Combating Challenges of the 21st Century through Innovation will be held on the 2nd and 3rd of October. It is an open exhibition where anyone who is interested in inventions and innovations can participate. The winners will be chosen by a panel of judges, and all the submissions will be presented to the general public through a website. This is a great opportunity for all inventors and innovators who are willing to create something new and make a change to the world. The winners will receive valuable cash prizes and scholarships as follows. For the first place winner, a cash prize worth 20,000 rupees, first runner-up 15,000 rupees, and the second runner-up 10,000 rupees. The first place winner will also be awarded with 3 full scholarships on Step into Robotics, PCB Designing Advanced, and 3D CAD Designing and Rapid Prototyping courses. The first runner-up and the second runner-up will be awarded with 2 full scholarships on PCB Designing Advanced and 3D CAD Designing and Rapid Prototyping courses, and also a scholarship worth 50% on Step into Robotics. In addition to this, the first place winner will receive a robot kit worth 15,000 rupees and the first runner-up will receive a development kit worth 14,000 rupees. Everyone else who submits their work will be awarded with 2 scholarships worth 50% on PCB Designing Advanced and 3D CAD Designing and Rapid Prototyping courses.
Thank you, Tarushi. And with that, the second session on PCB designing comes to a close. Mr. Randa Pushpika, I thank you for taking the time to join us tonight and gracing us with your knowledge. Tonight was a very enlightening session, and once again, I would like to thank you. And also, I would like to thank all of our viewers for participating tonight, and I invite every one of you to join us again for the third and final session, which will be held on the 27th of September. Good night, everyone, and stay safe. Thank you again for joining with us tonight.